new unit, and we're going to talk about solutions. At the very beginning here, we're going to talk about mixtures and solutions. How are they the same? How are they different? Our learning target, I can investigate and distinguish between solutions and mixtures by analyzing their composition, properties, and method of separation. Okay, so all of the compounds that we've used so far in this class, they have all been pure substances. Okay, that means that they are substances that are not mixed with other substances. For example, salt, right? Salt is one thing. You can, put it in your hand, you can feel it, right? Water, again, you can put that in your hand, you can feel it, right? It's not mixed with anything else. The same with an element, copper. Okay, but now we're going to talk about what happens when we mix substances together, right? Those are called mixtures. And a mixture is a sample of matter that contains two or more pure substances, right? So over here, these are two different types of mixtures, okay? So you can see that they're two distinct different compounds here, one red, one green. They both have red and they both have green. But there's differences between them because mixtures can be either heterogeneous or homogeneous. Okay? A heterogeneous mixture contains substances that are not evenly mixed. Okay? So a heterogeneous mixture, right? The particles are kind of randomly placed, right? They usually, the different substances can be seen. So, for example, our chocolate chip ice cream, or I don't know. Anyway, you could see the difference between the vanilla ice cream and the chocolate chips or chunks. Okay, sand in water. If you mix them together, right? Eventually, after you let it set for a while, the sand will fall to the bottom and then you'll have sand and water. Okay. So that's a heterogeneous mixture. A homogeneous mixture contains substances that are evenly mixed and uniformly or evenly distributed. Okay. So a homogeneous mixture has, a pattern to it. My pattern here happens to be one red, one green, one red, one green, and then, same thing going down. In this case, the different substances can't be seen. So, for example, salt water, right? If you get the salt to mix into the water, right, then you can't see the particles till they settle. Gatorade. Gatorade is a bunch of different substances. You've got coloring, you've got electrolytes, you've got water, you've got what is it called? Syrup, stuff like that. And so when they mix those all together, and they shake it up, the substance itself, or all the substances come together, right? And they kind of stick in that area. They don't bond, but they stick. And so they kind of look like they're one thing. Okay. A stable, homogeneous mixture is known as a solution. Okay. A solution has to be homogeneous, right? Sand and water are not a solution because that solution, those sand particles, can settle out over time, right? So a solution is made of small particles that will not settle out over time. Salt water. Okay. Air. Air is made up of nitrogen, oxygen, hydrogen, and helium. Oh, and chlorine. And but they're all together. They don't settle out into, you've got chlorine on the bottom and oxygen, and then, they don't settle out so that you can see them. Okay. Um, tea or soda, right? Specifically with tea, you're taking a solid substance and putting it into water. It dissolves, and then you just have the tea, right? Um, solids like brass. Brass is made out of copper and iron. Okay. All right. Solutions have two parts. The first part is the solvent. A, the solvent is basically, it's usually a liquid, but it could be a gas, and it's a substance used to dissolve other substances. So in this class, we're usually going to use water as a solvent, but it could be oxygen, it could be vinegar, it could be uh, oil. Okay. So there are many different things that you could use as a solvent. Okay. Um, and then the solute is the substance that will dissolve in the solvent. Okay. So it's usually a solid material, but it doesn't have to be. Okay. For example, in air, nitrogen is added to oxygen, right? Oxygen is the solvent, nitrogen is the solute. Okay. Um, the solute is whatever it is that you're going to dissolve in the solvent. The solution is the two of them together, right? And they look like one thing. Okay. All right. So to sum it up, we have pure substances are elements or compounds that exist by themselves. Okay. So let's say that this is water and this is sand. Water exists by itself. Sand exists by itself. Okay. A mixture is when two or more pure substances are put together, right? So water exists by itself. You can put sand into the water, that becomes a mixture. Okay. Mixtures can be heterogeneous or homogeneous. Heterogeneous means that they're not evenly mixed. Most mixtures most heterogeneous mixtures can be separated into its two or more components. A homogeneous mixture contains substances that are evenly mixed and uniformly distributed, and you would have to perform some pretty elaborate uh, experimental methods to separate them. Okay. So heterogeneous, they can be easily unmixed. Okay. Homogeneous, it's not that easy. Okay. All right. And then solutions are stable, homogeneous mixtures. Okay. It's important to when you write these definitions that the solution has to be homogeneous. Okay. Made of small particles that will not settle over time. Again, this is very important. Okay. If you put two mixtures together and then you come back later, or I'm sorry, you put two compounds together and mix them. If you come back later and they're separated, right? that means that they are not a solution. Okay. Solutions have two parts. There's the solvent, that is the substance that's used to dissolve, right? Usually like water or something like that. The solute is a substance that will dissolve in the solvent, right? So they're usually uh, solid compounds, small compounds like salt. Salt goes into water that becomes a solution. Okay.